fascistic. I mean, it's an amazing platform. It obviously, like this, it's unbelievable. Unlike you, I remember a time before it. 2004. So like, yeah, no. 2004 is the dawn of YouTube. So I mean, you may have been around, but I don't think you have a whole lot of digital memories. I could be wrong, but yeah, in 2004 we were in the pre-YouTube era, and life was worse, I can assure you. But YouTube does have this thing where it like really wants to tell you what to watch, and it's weird that like I don't know. I have a Google account. I've been watching a lot of YouTube. And it does not seem to have me figured out. Like things always pop up and I'm like, not only am I not interested in that, I'm almost actively anti-interested in that. And yet here you are recommending it to me. I don't know.
Like you watch one video and you didn't read.
Well, especially because you might watch something because you're because you're fascinated by like, you know, like I don't know. I watch like Jordan Peterson videos, not because I think Jordan Peterson's a brilliant mind, but because I think he's a hack who has like a lot of sway on a lot of people. But now like YouTube's convinced I'm like an alt-right guy, and it's like, no, I just was curious to see what this guy was saying. Anyway. Like, yeah, that autoplay feature, you got to keep that thing off, because all of a sudden like you'll wake up from a nap and be like, what am I watching? What is this? Why are they reenacting medieval battles? Why? Just stop. No more medieval reenactments.
You're having the background.
Autoplay
And just see where I am in like an hour.
Come back.
Yeah, see that. I don't know. I feel like it could end up. Just wake up and be like, that's the one thing it has me figured out is it sends me a lot of like science stuff, which is great. That sends me some stuff that's beyond my level of understanding, and I always feel dumb. So I feel like if I went on autoplay, I'd wake up to some guy just making me feel really stupid about physics. Okay, so we have been talking about organic compounds, and first we talked about just straight chains of carbon, and we call those, I don't remember, alkanes. We have a whole naming system for them, right? 1 carbon is methane, 2 carbons is, I think 9 carbons is? 5 carbons is? You got it. And then we said, of course, there can be branches off of that, so we have to start naming those branches, right? So you could have like a 2-methyl pentane, and that would mean make a pentane, make a 5-carbon chain, but on the 2nd carbon, add a methyl group, add methane, add 1 carbon, right? So that's pretty straightforward. We talked about double bonds. How do we indicate that in a name? Ene. And of course, we need to put a number in front of that if we need to put a number in front of that. We talked about triple bonds. Fine, yeah. Yeah, I know Y can make either sound, but for differentiation purposes, we're going to say the E makes an E sound and the Y makes an I sound. And then, on the last day, we talked about the easiest thing you can stick on there, which is instead of a hydrogen, what fits really conveniently in any location on an organic compound. What? And halogens, yeah. And in fact, in a couple of, maybe next week, we will learn how that's done, like actually physically in a lab, how you take a straight chain of carbon with hydrogens and you, well, next week we'll hear together, and how you actually stick a halogen in there. Yeah, of course. Why do halogens substitute nicely for hydrogen? 7 electrons, which means that their tendency is to want to make how many bonds? 1, just like hydrogen. But they have more interesting chemical properties because they have varying electronegativities. They cause the thing to become polar, potentially. Interesting things happen when you put a halogen on. But today we're going to talk about even more interesting additions we can make to organic compounds. So today we're going to introduce our first 3 functional groups. All right? Functional groups. There we are. As the name would suggest, a functional group is a group of atoms we can put on a hydrocarbon that has a function, that does something, that behaves a certain way chemically. So we're going to talk about 3 of them in particular. We're going to talk not about what they do chemically yet. First, we're going to learn what they look like and how we name them. And that's, I've sort of divided this unit into two ways. There's kind of two major ways to teach this. One would be teach like about alcohols, how to name them, and then teach all about the reactions and things like that, and then come back a day later and do the same for ketones. I prefer to spend a good 5-6 days in class focusing just on naming, making sure we understand the shape and how to draw and how to name everything, and then talking about reactions. I just think it helps if you always have a good solid sense of what these things look like, and naming becomes important because you have to know names of things. So that's my thinking. So first I want to talk about alcohols. An alcohol is any compound that has a hydroxyl group, an OH on it. So an alcohol has an OH attached to at least one of the carbons. Obviously, the most commonly known alcohol is like the one we drink, right? I mean, you don't drink because you're young, but I drink occasionally because I'm not young, right? So we drink wine and beer and spirits and things like that, and they have alcohol in them, and we use that word kind of pejoratively. Does anyone know, I think it's, oh, it does say on here, specifically what alcohol that is? Ethanol. Draw ethanol. I've just told you what it is. Draw it. Sorry? Well, ethanol's interesting. See if you can figure it out. Or like where on the page do I want to draw it? Yeah. In the big space. In the big space under the paragraph about ethanol. No. No, we're going to draw it nice and big. It's going to take up that space. My tricks? I'm not tricky. I'm basically the opposite of tricky. I'm a bit of a powder puff teacher. I am. Like my tests are easy, my exams are easy. Oh, come on. I don't aim to trick.
It's like from the other time.
You forgot to what?
She's like, I don't remember.
Have you texted home? You should text home. You should text home.
I did this last week too.
Don't feel bad. It's okay. I once reported my car stolen. The point is, sometimes we forget things. I'll tell that story later. It's a long story and a really good one, but there's no time now. So let's focus. So ethanol obviously is on a backbone of what alkane? Ethane. And ethane is what? 2 carbon. Oh, that's a highlighter. So 2 carbons like that. And of course, normally it would have what on each of these? Hydrogen. Now, we know that because it's an alcohol now, it's going to have 1 OH. Does it make any difference in this case what bond that is? Does it matter, though? No, these are completely symmetrical, right? So because they're completely symmetrical, it makes no difference which bond we put on. And because there's only 2, it makes no bother which carbon we put it on. I'm going to put it right here. And if you put like an O and then a bond to another H, that's not wrong. In fact, it's right. You've done a more kind of careful job than I have. But more often than not, we'll just draw it like this. But if you did this, that really is technically more correct. Well, no, that's not fair. That is more descriptive. That shows what it really looks like. But we usually just draw OHs together because they come together a lot. And of course, we could also draw this as CH3, CH2, OH. What is never done, we would never count that hydrogen in the same group as these hydrogens because it's distinct. It's not bound to the carbon. It is bound to the oxygen. And if I wanted to make this a chain, of course, I could just say 1, 2, and then to OH. Those are all the same drawing. I mean, different drawings, but those are all drawings of the same thing. Questions about that? That's comfortable, yeah? Okay, now, come on. There we go. How do we name this? Well, we name it by adding all. So let's draw this. Let's say 1, 2, 3, 4, 5. And let's try this. Okay, there we go. Because most devices that have motors for the vibration thing have 2 of them with different size weights to produce different speeds of vibration. What? Actually, I took one apart out of an old Xbox 360 controller last semester, and all it is, it's just a motor with a weight on it, but instead of having like a nice balanced weight, it's a weight that's all on one side of the spindle, and so as it rotates, it's just unstable. It's like an unbalanced washing machine, and it just shakes. Anyway. Okay, so let's talk about this first one. What is the main chain here? One, two, three, four. What would we call this? Good, so this would be pentane, but now it's no longer a pentane because it is a pentanol. And in this case, with 5 carbons, does it matter where we put the OH? Yeah, so we have to indicate where it's put. So how are we going to number these? Well, I could go this way, or I could go this way. And for this particular molecule, does it matter? Nope. So what would I call this? Pentan. Very good. Pentan-3-ol. Again, if you see people using an older naming system, you may see this as 3-pentanol. It's not wrong. It's just out of date. It's an anachronism. But this is a much better naming system. You will see, because in the old naming system, there might be 3 numbers in front of the pentan, and you would have to keep track of which number goes with which ending, like by looking at the order. That got chaotic. Here, nothing chaotic about it at all. It's just right next to the functional group. Does that make sense? Okay. I want to mention that here we have to choose between giving the alcohol a low number or giving the side chain a low number, right? If we label this way, it'd be 1, 2, 3, 4, 5, 6, 7. If we number this way, it'd be 1, 2, 3, 4, 5, 6, 7. Which one do I choose?
Wouldn't you go 1, 2, 3, 4, 5, 6, 7, 8? Like going off of the.
Oh, you're right. Good eye. Very good. Yeah, so this is actually the side chain. I outsmarted myself, which I can assure you doesn't take much. Or we could go 1, 2, 3, 4, 5, 6, 7, 8. And yeah, we give numbering priority to the functional group. So you can make a little note about that if you want. Functional groups get numbering priority. And that just means it's more important to keep their number low than to keep a side chain number low or to keep a halide low. Functional groups are more important.
I think you have to go with the rate anyway, since if someone would appear second, unless you would go the other way.
But even if it didn't, we always give the functional group the net numbering priority. In other words, even if the side chain was on 2 and the functional group was on 3, we want the functional group to have the lowest possible number. Always, 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 always. So if there's a functional group, don't worry about chains. When you're picking your ordering side, worry about the functional group. And don't worry, once we know about a bunch of functional groups, you're going to get a big old list telling you which ones are important. Okay, so if this is our main chain, we say our main chain is a what? Well, we have 8, so octane. Okay, talk to me. What else do we know about this thing? I'm going to need some room this way, obviously. You know, so guys, just highlight the writing on your page and just shift it over a little. What can you tell me about this? Yeah. Okay, so it's got a 5-methyl and a 6-methyl. So we would call that a 5,6 dimethyl. Okay, what else? What else can you tell me? OH, which is what? 2 what? Right? So how do I put these into the name then? Who wants to be brave and give me the name of this whole thing? Yes, ma'am. Very good. It's horrible. It's such an uncomfortable thing to do. So a 5,6 dimethyl octane 2-ol. I was about to tell a story with this recording. I'm not going to tell with this recording, but I'm going to tell it at the end of class. Because it's incriminating. It's not incriminating, it's just...
Yeah, but now the people watch the recording and I never been
and you'll never know what I talked about. Okay, this could also be present with alkyl groups, right? So I could say, oh, I wanted black. So I could say 1, 2, 3, 4. I could have bromo. What am I doing?
I don't know.
I'm going to put that there and that there. Sorry? That's bromine.
What was the thing again? It was like a TBN. That's an F.
Yes, I was attempting to draw a TV antenna. You cracked the code. Congratulations.
It's like a line with like 2 lines against it.
Let's do the first one together, and then you can do the second one individually. Okay, how long is our main chain? 1, 2, 3, 4, 5. Now in this case, I can do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now that OH has to get priority, right? But in this case, it doesn't matter. So since it doesn't matter for the OH, which one's better overall? Good. All right. So this would be considered a what? Really good. A 2-bromo. And this, of course, will be a 3-ol. All right. Who wants to be bold and give me the name of this guy? Yeah, Zach.
2-bromo pentane.
Very good. 2-bromo pentane 3-ol. Remember that we only put dashes between numbers and letters. There's no spaces, there's no capitals. Yes, it's its name, but it's not a person, so it doesn't get a capitalized name. don't know if I mentioned that before, but that's of note. All right, you try the one on the right. Yeah, that's all of the periodic table elements, and we all have a nasty habit of sticking capitals on them from time to time. They're all lowercase. There's no names on there.
I know, but like
the symbol? Yeah, we use a capital letter in the symbol, but when you write the name, it's lowercase. Because it's not like your buddy Titanium, like it's just a thing. Then you would capitalize it. So if you have a friend who names his son or daughter, because it's 2018, kids, if you have a child named Titanium, you can capitalize that. But if it's a lump of metal, just like, this is a pen, it's not pen, capital P, right? Like, Pen and I are going to the store.
Well, if you're going to the store, I'm pretty sure you should reskin the capitals.
That's right. One, two, three, four. Yeah, that's allowed. Hey, I'm right here. I'm right here. I'm right here. Who says that?
You hear what Kevin said?
No.
He says, let's go read a bedtime story, Phosphorus.
Okay, you're not wrong. You're not wrong.
The conversation is said in this class.
That worse. All right.
Worse, in other words, like seeing where they're seeing on the piece.
No, it's not.
You see, this part of chemistry I actually enjoyed. Because it was like, just like a number of
Why do you separate it if it's a triple bond?
It's not necessarily separate. It's not separate. Those should touch. There you go. Yeah, this is nice, right? Because it's just factual. It's just name it.
Oh, you're not supposed to remember it. Yeah,
That's why the screen is frozen. Then you have to undo it.
yeah. I think you did that. Remember.
I don't think it did, because I think I gave you a note up top that said what gets numbering priority.
I wasn't there for that part.
Ah, that's okay. Now you've learned. We always give functional groups the lowest number, no matter what,
How come Bobo got to have?
because it's not a functional group.
Yeah, it wasn't.
No one cares about bromo.
I'm confused.
Because OH is in the middle either way. So
Yeah, in that case, it didn't make a difference, but in this case, it does.
Well, now I
Yeah, we're not going to go out of our way to give higher numbers, because the better name is always the name with the lowest possible numbers. But even more specifically, we would rather functional groups have low numbers than anything else.
well, now I have to rename this.
This is kind of
Yep.
like an out there, but
Hmm.
what would change, like, so on this side, like, we have the story already out there, but what would change if, like, we moved it over? Like, what, like,
How would its chemical behavior change? No, it's a great question. It could change in a lot of different ways, or it could change not appreciably at all. You can think of it this way. On your car, if you moved the buttons for the radio, the practical difference in the usability of that car doesn't change, right? Even if you move them someplace really stupid, like even if you put them in the back seat, it'd be annoying, but the main function of your car doesn't change, right? On the other hand, if you move the steering wheel to the back seat, but keep the gas and the brake where it is, now you've very fundamentally changed the functional nature of that vehicle. Does that make sense? Right now, the whole way you can or can't use that vehicle has changed. Where if you wanted to drive it, which you shouldn't because it would be really unsafe, you would have to have like one person in the back steering and one person in the front operating the pedals, right? That's a big change. So changing a bromo one carbon over probably would have a pretty small change. Though again, I'm not a strong enough organic chemist to have a really good answer to that question, but my instinct is that would be a relatively small change. And one of the reasons that we give functional groups numbering priority is that side chains and halides tend to be important because they change like the van der Waals forces, but they tend not to have a lot of chemical activity outside of that, whereas an alcohol has a lot of chemical activity. So moving an alcohol is like moving the steering wheel. Moving a bromine is more like moving the radio controls, in that very poor analogy.
That is a very important function of a car.
Yes, exactly.
If
And
you
the
can't
alcohol,
reach the stereo,
yes.
someone's going to die.
Oh, you mean the stereo? Yes. Some of us just used to have vehicles where there were only gaping holes where stereos used to be, because I had not one but 2 radios stolen in Rochester, New York, on 2 separate occasions. 2 different times in my life. I went to a concert in Rochester and came back without a car stereo.
But
Maybe
was
it was
it
the
the
same
same car?
Yes, I had paid to replace this. No, that's not true. I did pay to replace that stereo, but they actually were different cars. Actually, only one of them was mine. I had a radio stolen on at a Great Big Sea concert in Rochester. Great show. And then we saw Bare Naked Ladies, and my friend Chris had his car stereo stolen. Same parking lot, same venue, Rochester, New York.
Same job, too.
They did a lovely job. It was like if you'd asked somebody to professionally uninstall your stereo, this is the job they would have done. They took the disc out and left it sitting on the seat. Like, isn't that considerate? Like, I'm stealing your stereo, but I don't want to take your stuff. Keep your CD.
Maybe they just matured.
Just the second one. Yeah. But can you imagine, like, removed the CD, but locked the door behind them? Like, very considerate.
Now no one else.
Because I will never forget, the second time we had talked about how my car had been stolen. And my friend Chris got in, there was a CD like on the center, and he's like, oh, thinking like he'd taken it out. And he grabbed the CD and like reached it. And of course, there was just a hole in the dash. I was like, you've got to be kidding me. Twice, yeah.
Figure 6 or 5. Which one gets priority within the name?
Functional groups beat double or triple bonds. Okay, so let's take a look. What do we have as a name for this one that I've started here, that I've highlighted? Yeah, what do you got?
5 fluoro 7 fluoro 10 2O.
That's like a 90% answer. I really like it. There's one thing I don't like. Only one thing I don't like. What don't I like about that? Because I mostly like it. I'm like, that's really good. All the numbers are right. All the names are right. There's something I don't like about how you put them together. Yeah, what order should the beginning ones be in? Alphabetical. So instead of being 5 fluoro 7 chloro, it should be
7 fluoro 5 fluoro.
very good. 7 chloro 5 fluoro heptane 2 all.
Remind me, why isn't the bond where the chlorine is? Why isn't that one?
Because because functional groups get numbering priority.
Okay.
Again, it's that idea of like the steering wheel and the radio. Functional groups are the really important part of an organic molecule. They give it its chemical characteristics, and so even though one way gives us a number 1 and the other way gives us a number 2 as the beginning, if there's a functional group, in terms of how to number, ignore everything else. That functional group is going to be the key. Does that make sense?
Yeah.
That's a great question, by the way. Here we have a double bond. Now that double, first of all, how are we going to number this guy? This is obvious. 1, 2, 3, 4, 5. Yeah. Because it gives us the lowest numbers no matter what, right? But this double bond, how do we number? What's this going to do? How's that going to affect the name? Yep, specifically. Good. So 2-ene. And then this is our first time with 2 alcohols. That's okay. We've got a 2-all and we've got a 1-all. How am I going to write that?
1,2.
Yeah, and how am I going to say that there's 2 of them? Very good. So this will be, maybe there's a secret message in the examples. Maybe. You're giving me way too much. Oh, but not pentan. Not pentan. Pent. Two. In. But because we're not done, we have to drop that last E, right? There's always an E right at the end of an alkane or whatever, but because we're not done. And then how am I going to say these alcohols? You said it. You were right. 1,2 diol. Pent 2-ene 1,2 diol.
So does the bonds go first for the name? Or
Yes. Yep. Yeah, functional groups always go at the end.
So, if we're talking about, is it ein?
Mm-hmm.
Oh, that's easy to remember because it's alphabetical order.
So this is going to be 1, 2, 3, 4. 1, 2, 3, 4, 5. And which way are we going to number it? Which way? Which way is that? I'm facing a different way than you.
from the O.
Yes, okay. It's one of the first things you discover as a teacher is that, like, when you're talking about math graphs, you always have to go like this, which looks backwards to you. Like, because it's like a mirror, right? I'm facing you. So you don't think about this, but like when your grade 9 math teacher is like, a positive relationship goes up and to the right. He has to, of course, go up and to the left to make that happen, right? It is disorienting. So your hand signs always have to be the opposite of what you want them to be. Right? Exponential curves look like this. Well, it doesn't look like an exponential curve to me. It's like the loser sign. When I was like in grade 6, that was a big thing. Like, and like you had to be careful because if it looks like an L to you, who's the loser?
I never understood the
Right.
I don't.
Well, the trick is to draw an L here, and then that would look like an L to me. So to you, it looks. That's right. So if it looks backwards to me, it looks anyway. Anyway. Obviously, you weren't children in the 90s because that was an important life skill to have.
I thought it was running in the
Wait,
90s.
You thought it was what?
You said chilling in the 90s. I think it was running in the 90s.
I said being a child. You weren't children, not chilling. We didn't chill. That wasn't a thing yet. Okay, what is this going to be? This is a 2 something.
Oh, never mind. I'm thinking about the triple.
Yeah. 1 what? 1 all? Okay, and what about our triple bond here? This is going to be a 2 ein. Good. Now, why do I call it 2 and not 3? Yeah, you go with the lowest number it touches. And so altogether, what's the name of this fine fella?
Ein 1 O.
Pent 2 ein. Oh, should be.
So I think that was an I.
Pent 2 ein 1 all. And I think we will do just one more functional group today. That true? Yeah, that's true. And then we'll catch up on the third tomorrow. We'll see, because they're simple. They're the same. But yeah, maybe we'll even stop at alcohols. We'll see. We'll see what happens. Okay.
We could wait till we're 19 right now.
So now we classify these as primary, secondary, or tertiary alcohols. Primary, secondary, or tertiary alcohols. And the trick to that classification doesn't actually deal with the alcohol itself. So this deals with the carbon it's attached to. So we're really classifying the carbon attached to the OH. These are all primary alcohols. What do they all have in common? Good. The OH is always at the end. That's true. Now I want you to focus on not the OH, but focus on the carbon it's connected to. This carbon, and this carbon. They're all what? They're all the first carbon. And specifically, they are attached to, obviously, the OH. What else they are attached to? Good. So this is any other carbons? So this is an alcohol bound to a carbon. Less common spelling of 2 with an A. Bound to a carbon which is only bound to one other carbon. So really, the primary means 1, right? Secondary means 2, tertiary means 3. What that's really counting is how many other carbons that carbon is connected to. So primary alcohol is an alcohol attached to a carbon that's making 1 bond to carbon. You're counting carbon bonds, all right? Which means you can tell me what a secondary alcohol would look like. If I draw this chain, where could I put an alcohol that would make it secondary?
You can put it on number 2 or number 3.
Good.
Well, either case can be.
But that's right. I can put it in the middle. Does that make sense? Because this carbon is bound not to 1 carbon, it's bound to 2 carbons. I want you to draw a couple more secondary carbons, or secondary alcohols, rather. I'll give you the chains to work with. Or just make your own. Like, it doesn't matter. We just want a few examples. If you want to draw decanol, you can draw decanol.
I think I know what they're doing.
Of course, decanol isn't a thing, but like decan-2-ol is a thing, or 3-ol, or 4-ol, or 1-ol. But yeah. Yes. And this is actually a really significant difference. It really matters. There's very different chemical behaviors at play. You'll learn about why in a bit. For the moment, you'll just have to take it on faith. Yeah, that's good. So, where could I put an alcohol on this one? This one? This one? This one? This one. Here?
Yeah.
Perfect. That works. Because that carbon is connected to 2 other carbons. Where could you not have put it? On the ends. Good. What about this one? Good. It has to go on the middle. All right. So OH bound to a carbon that is bound to 2 other carbons. And the easiest way to say this is inside the chain, right? That's really what we mean in this case, that we're an OH stuck to a carbon that's inside the chain, right? Whereas in the first example, it had to be on the end of the chain, on the outside. Outside's good wording. Inside the chain, outside the chain, absolutely. Does that make sense? Now, so we're inside the chain or we're outside the chain. What's this third option? What's tertiary mean?
Where two like connected to the chains that like go outside the chain.
So I like your thinking. So we need a side chain.
Yeah.
So I'm going to draw this, and I'm going to put maybe a side chain there and a side chain here. Just for example. Okay, where could I put an OH here? That would make it a tertiary alcohol. Remember, we said a secondary alcohol touched a carbon that was making 2 bonds to carbon. A primary alcohol was attached to a carbon that was making 1 bond to carbon. So where could we put it here that would make it tertiary? Could I put it here? What would that be? That'd just be secondary. Okay, so that doesn't work. Could I put it here? What would that be? That'd be a primary, so that's not good. Where could I put it here? Could I put it here?
I feel like girls necklace for the hit or miss lottery.
Yeah.
No, you're just like.
That's a reference that I don't understand.
You still have cable?
You know, not far from still, we got cable this year for the first time in my life because I was hosting the Super Bowl, or last year, sorry, because I was hosting a Super Bowl party. So now I have cable, but I don't really watch TV. I don't know how people watch TV. I don't know how when I was a kid I used to watch hours of TV. If I watch TV for 20 minutes now, the advertisements make me want to like scream. I can't handle it.
I can't watch
Pre-recorded.
Yeah, so you can skip it. Like even if I'm watching a football game, I will record it, and then an hour in I will start watching so I can skip all the ads. But football is so terrible. You need to start like an hour and a half in because the ads just never end. It's like 1 minute of football, 4 minutes of ads. It's unbearable.
I was watching a show and I'm like, okay, it's like it only
Sorry?
takes like 5 minutes and then it takes like a 10-minute break.
Yeah, I can't handle it. It makes me feel crazed. Okay,
The girl
2 songs later.
It's like always
Like 2 songs later. If you listen to this, like a bit.
It believes that you got it.
Do I have to actively like tap the screen to know I'm listening?
okay. Where could I put an alcohol on this fine fella? Yes, ma'am.
You can put it on the kind of, I don't know what you call it. I guess you would call it the.
Well, what would you call this? This is what kind of group? That's a methyl group. What's this? A methyl group. And what's this? An ethyl group.
Put it on the ethyl.
Yep. Of course, that would no longer be 4, right? Because now that would get numbering priority. But you're right. As the chain was before, it would have been number 4. And there we go. Good. And obviously, I could have also put one here. And obviously, I could have also put that one there. And yes, we can count different chains there. Any of those would be tertiary. So this is OH bound to a carbon. That is bound to 3 other carbons. Is there such thing as a quaternary alcohol?
I don't think that's possible
Why not?
because carbon can only have 4 chains.
Carbon can only make 4 bonds. So if carbon were bound to 4 other carbons, could it also bind to an alcohol? No. Under normal conditions, no. I'm trying to think if
Normal.
I'm trying to think if those can carbon have an expanded octet. I don't think so. I think that one actually will not happen. But
Can you have an OH?
But keep in mind again that we teach you a relatively simplistic version of things, right?
What if you have an alcohol bound to an alcohol bound to?
So you need to be able to, sorry?
What if you have an alcohol bound to an alcohol?
You can't, because how many bonds does oxygen make? Just 2. That's right. So that can't happen. So a hydroxyl group is also terminal. it also ends the molecule, right? But it has a lot of interesting chemical behaviors. I can assure you, if you ingest ethane, first of all, it's a gas, not a liquid. Second of all, it does not have any of the sort of effects that one would expect from alcohol. It's very different from ethanol. This small change. By the way, ethane is a very light gas. Ethanol is instantly a liquid. What's changed? What do you think? Not appreciably. I mean, we've tacked one oxygen in the middle. It's not much bigger, though. You're good thinking. So you're thinking London forces. Yeah, I don't think that's a big enough change to give us London forces. But what do we now have that we didn't have before? It is polar, which means what kind of force is now at play? Hydrogen bonding, which is, of course, a type of dipole-dipole. And that is a stronger bond than London dispersion forces. So this thing would go from being a gas to being a liquid. Do I want to teach you one more? I don't, actually. I want you to... No. No, I mean, I do want to teach you, but I think I want to wait till tomorrow for that. We'll get through those two. So I have put up online some practice for naming alcohols and some practice for the next half. I've got the answers there. Obviously, there's nothing to be gained by just looking at the answers. So I encourage you to do them first. So I'll leave these up here for now. You can grab them at home on your computer or on your phone or whatever.
What about if you want to get out your
Oh gosh, you want to hear the Cars story?
Yes, please.
All right.
Oh, no, one. It's like your mom's thing.